In chemistry, when people are trying to decide which chemical reaction to use, it's really important that these reactions have got a high atom economy. Now, atom economy is essentially a measure of how many of the atoms that you start with go towards making what we call a useful product, so something that we are desiring as part of the reaction. So, without further ado, we'll look at how we go about calculating atom economy and how we can use that in chemistry. So, question 2 on the resource. We're told propane, C3H8, it can be produced by the hydrogenation of propene, and we need to calculate the atom economy of this reaction. And it's only worth 1 mark, and it doesn't actually give you any relative masses in the question either. So you might be thinking, well, hang on, how am I supposed to do any calculations here? Well, lucky for us, we don't need to. In an atom economy question, if there is only one product in your reaction, and it is the desired product, because of course it must be, it's the only thing, then that means all of the atoms from the reactants are being used in the product. And if all of the atoms are being used, then that means that the atom economy is 100%. Okay, all of them are being used. There's nothing more to say. They're all there in that product. They're all useful. So if you said 100%, well done. Give yourself a tick. Now, not all examples of an atom economy calculation can be this nice, unfortunately. So sometimes we might have a question like this. We're told in the question that mercury, which has the formula Hg, can be produced by the breakdown of mercury oxide, and we need to calculate the atom economy of this reaction. Again, like we saw with the percentage yield questions, it is telling us how many significant figures to give our answer to. And this is a 4-mark question, so there's a lot of work to do for those 4 marks. Now, the first thing we need to identify is which of the products is the useful product. Now, it tells us in the question that mercury can be produced by the breakdown of mercury oxide, so mercury is our useful product. The oxygen here is not a desired product. Now, in order to find the atom economy, what we need to do is this equation just here. So it is a percentage, so we will need to times it by 100 at the end, but we are doing a comparison of the sum of the relative masses of the useful product or products, depending on whether there's more than one, and we're dividing that by the sum of the relative masses of all reactants, so what we're starting with. Okay, and again it's a percentage, so we're timesing it by 100. So let's have a look at this. How are we going to do it? Well, first of all, we need this bit on the top, so I'm just going to label this A and label this B so you can see what I'm doing in each part of my calculation. So part A, the sum of the relative masses of the useful products. Well, the useful product taken directly from my balanced equation is 2 moles of Hg. So what that means I need to do is I need to take the relative atomic mass of mercury, Hg, which is 201, and I need to multiply it by 2. Now if you do that, that gives you an answer of 402. That's your first mark, because you've identified the total relative mass of your useful product. The next thing you need to do is the bit on the bottom here, the sum of the relative masses of all reactants. So your reactants are in that second box I've just drawn over the balanced equation, 2HGO. So HGO is 201, once again, plus 16 this time because we've got the oxygen in there, but we are going to need to multiply that by 2 because of the big 2 in front of mercury oxide. So if we do 201 plus 16, that's 217, multiplied by 2 is 434. If you got that, then that's worth your second mark for this question. Now we need to substitute those numbers into our equation. So the sum of the relative masses of the useful products, that's 402. We're dividing that by the sum of the relative masses of all reactants, 434. And because it's a percentage, we're multiplying our answer by 100. If you do that, you get an answer of 92.6267, and there's a few other numbers there after the decimal place. But once again, if we get this number, that's a third mark, but we do need to calculate it to three significant figures. So this 6 is the third significant figure, so we need to look at that 2 and see if it's more or less than 5, or 2 is less than 5, so we are rounding down. So therefore, our answer to three significant figures is 92.6%. Now, one thing that you can always do to double check your answer here is if you've got an answer that's greater than 100, you know you must have made a mistake, because it is a percentage and 100% is the maximum atom economy for a reaction to have. You can't just make atoms out of thin air, okay? They've got to come from the reactants themselves. So the fact that we've got 92.6%, it's lower than 100, that's what we're looking for. The other 7.4% that we're missing there will be due to the oxygen as the waste product. Okay, so that's our atom economy, and if you've done that to three sig fig, that's the fourth mark. So we'll go through one more of these atom economy questions, so 2C, where we're told that phosphoric acid can be produced by the reaction of sodium phosphate with hydrochloric acid as detailed by the balanced equation below. So the key thing to note from this first sentence is that we are looking at the production of phosphoric acid. That is our useful or desired product. So I'm just going to make a note of that there. That's the useful product or the desired product. Doesn't matter what you call it. That's where we're going to start. We then need to consider what the atom economy for this reaction is. We need to give our answer to three significant figures once again. So first things first, we know atom economy is equal to the sum of the relative masses of the useful products. I'm just going to abbreviate it to useful products, divided by the sum of the relative masses of all reactants. I'm going to label those A and B once again, and we're going to multiply that by 100 because it is a percentage. So let's consider A first of all, our useful products. So this time it is just H3PO4. So we need to find the relative mass of the phosphoric acid. There's no big number in front, so we don't need to multiply it by anything. So we've got 3 lots of hydrogen, so therefore we need to multiply 1 by 3. We've got 1 phosphorus atom, so we need to add 31. And then we've got 4 oxygen atoms, so we need to add 4 lots of 16 as written there. If you do that, you add all of those numbers together, you get an answer of 98, and 98 is your first mark. For B, we need the sum of all of the relative masses for all reactants. So if we look at this here, there's quite a few of them. So I've put that in the box, and now I'm going to write what's down, or what's in that box down here. So we've got Na3PO4 plus 3 lots of HCl. So for the Na3PO4, we've got 3 lots of 23, as sodium has got a relative atomic mass of 23. We're adding that to 31. We're adding that to 4 lots of 16. And then we've got hydrogen and chlorine. There's only one of each atom in HCl. So 1 plus 35.5. However, this big 3 here means we have to times this number by 3. Okay. If you do that calculation, you add all of those numbers together, you get an answer of 273.5. You get that, that's your second mark. The easiest thing to miss there is the balancing number, that big 3 in front of the HCl. So do make sure you include it in your calculation. Now we've done that, we can actually calculate the atom economy. So we've got 98 divided by 273.5. We need to multiply it by 100 because it's a percentage. And if we do that, we get an answer of 35.8318. And a load of other numbers. And then once again, 3 significant figures. So we need to round this to that 8. Do we need to round up or down? Well, we need to look at the next digit. It's a 3, so it's less than 5, so we're rounding down. So therefore, our answer is 35.8% to three significant figures. So if you got that, that's all 4 marks. Now you notice the atom economy of this reaction is quite low, 35.8%. Now the only way to increase the atom economy of this particular reaction would be to find a use for that other product, for the sodium chloride. So you could use the sodium chloride and say, oh yeah, I'm going to use it as table salt, and then you've increased the atom economy of this reaction. But it is still quite low. So if you were looking to make phosphoric acid in industry, you might look for an alternative reaction. So that's atom economy. Hope it makes a bit more sense now. Thank you very much.